Welcome to my channel. In our session for today, we are going to discuss. About logarithmic differentiation. When it comes to the logarithmic differentiation, the first step that you need to understand is the law of logarithm, the differential coefficient of logarithm functions, and the differential of implicit function. So here you can be given a function y is equals to this one. The y is equals to what we have here, and this is a complex function. So our first step is that we introduce the natural log to each and every side. And by that we are going to have the natural log of y is equals to the natural log of everything on this other side. We are going to have 2x, we subtract from 1, the root of x So this is our first step. We introduce the natural logs on both sides, and by using the laws of logarithm, we are going to expand this one. So we will be having the natural log of y will be equals to the natural log of 2x minus 1. Since here we have a multiplication, we are going to have an addition of the natural log of x raised power. This is now our numerator, and our denominator we are going to have, we subtract from the natural log of x. Here we are going to add to the natural log of So this is how we distribute our natural log. After that, we still need to observe the natural log of power. Since when you have the natural log of a function f of x raised to power n, this one is equals to n natural log of a function f of x. So on this one and this one, we are going to drop the power. So here we are going to have the natural log of y, natural log of 2x, we subtract from 1. We add 2, here we are going to have a half to the natural log of x, and you are going to subtract 2 the natural log of this negative sign is going to affect the positive sign, and we are going to open our bracket by a negative of 3 all over 2 to the natural log of that. Now, after observing all the loss of indices to this logarithmic equation. Now we are going to do our differential. We are going to do the differential coefficient of the logarithmic function and the implicit differential of a function of y. By implicit differential of a function of y, after doing your differentiation, we are going to add to it a term of dy with respect to dx. Now let us do our differential with respect to this one. We are going to have this is now the implicit differential of the natural log of y. The differential of this one we are going to have is equals to the differential of 2x will be equals to 2 all over the term of this one, which is equals to 2x minus that we add to a half. The differential of this one we are going to have 1 all over x minus 2, and here we are going to subtract from the differential of what we have here. We are going to have 1 all over we subtract from 3 all over 2, the differential of this one we are going to have 1 all over so this a half is affecting only the numerator, and 3 all over 2 is also affecting only the numerator. Now after doing our differentials, we are going to have here, we are going to have now a term of dy with respect to dx only on this side, and by doing that we are going to have dy all over dx is equals to, here we are going to multiply by the reciprocal of y and also to the other side, so we will be having 1 into everything that we have there. We are going to have 2 plus 1. So we are going to have our term of y be multiplied by everything, and by doing that we are going to have dy with respect to dx will be equals to, our y is what we have here, so we are going to replace y with the whole of this function 2x everything is going to be all over So this is our term of y, and now we multiply by what we have here to have our answer. So we are going to have 2 all over. We add 2. We subtract from. And this is what we are going to have as our answer in case you've been asked to differentiate, to have the differential of this one. This is how you apply the rule of logarithm in differential of this complex function.